Hi, and welcome to the Daylight Solar Tracker Dashboard RadarSoft Capstone Project 2021 presentation. My name is Noah Soule, and joining me today will be Daniel Myers and Jeremy McNeil. Our client for this project is Sharp Energy and STracker companies. Sharp Energy is a renewable energy company located in Ashland, Oregon. Their goal is to bring energy efficiency and renewable resources and sustainability to our communities. Since 2017, Sharp Energy has focused on the startup company STracker Incorporated, helping to develop, test, and certify the solar tracker array, the STracker S1 dual axis PV power plant, while continuing to work with our communities. A solar tracker is an array of photovoltaic cells atop a 20-foot pole. The STracker allows landowners to maintain use of the land below for shading parking lots, allowing tractor access for farming, or just providing additional shaded area for the landowner. The STracker keeps the solar panels out of the way while maintaining the most efficient angle for photovoltaic production. The solar tracker actually tracks the sun, azimuth, and elevation throughout the day, stows at night, and stows during heavy wind events to the safe position parallel to the ground. So our project is a dashboard for these trackers. Currently, the engineers are unable to manage multiple trackers at once. Each individual tracker can be managed individually by logging in on location. So there's no remote access. And the log files are cumbersome and machine readable, but not human readable. So a human readable dashboard is our project. The concept broad overview is that the STrackers are communicating currently with a Raspberry Pi. That Raspberry Pi will communicate with a server and post the log files to the server, and then that server will be hosting the dashboard interface for the final end users. I'll now hand you over to I'll now hand you over to Daniel McNeil. Ouch. I will now hand you over to Daniel for an in-depth view of our architecture.
Hey, Daniel Myers here. Um, to start with a kind of broad overview of what we're looking at, uh, each tracker, right, has a microcontroller that reports to a Raspberry Pi over USB, tracking up to 18 trackers per Pi, which is going to be the maximum size of an array that we would potentially deal with. The current log files that are generated by each Pi are bulky text files that need to be accessed via command line locally. Uh, and as Noah said, right, the idea here is to create a dashboard that can aggregate and display all of this log file data in an easy to use and sortable interface for engineers to both monitor the current status of each tracker as well as be able to observe the historic status of each tracker. Uh, so to start putting these pieces together, now we have the at the center of our architecture is a DigitalOcean droplet server. It's running an instance of Ubuntu 20 and hosting a MongoDB database from which we will be retrieving and storing data. We're using an Apache Tomcat platform to help smooth out running our Java servlets, which is how we'll be parsing this data. And uh, we'll be running a UFW firewall as a general security measure to prevent unauthorized access. Uh, so the general idea with our backend is to accept data and store it in a MongoDB database. To do so, we've developed a REST API that currently functions by responding to posts sent via curl commands. The servlet that we've set up parses that data from a JSON format into a into a database format that MongoDB prefers, BSON, and then the servlet stores that data as a entry in the MongoDB database, which now makes it retrievable from our front end dashboard. The front end dashboard is set up to both populate itself and format itself automatically using JSTL and data tables, as well as use a separate Java servlet to retrieve data from MongoDB to deliver live updated information from each tracker on the dashboard. Here we have the entire architecture laid out, and as you can see, the project consists of a central server and two separate client-side connections. So the first client-side interaction is going to be the Raspberry Pi issuing JSON packets over HTTPS to the server. This is currently set up to be done via curl script, but any method of posting to the server at the correct port should be sufficient. The server itself is split into two Java servlets, one to handle back-end interactions and parse the JSON files that are posted to the server and store them in the MongoDB collection. The other servlet is designed to retrieve, sort and retrieve each of these JSON, or well, these now BSON records that have been stored in the MongoDB collection. The other client-side interaction that we'll be handling is that of the STracker engineer using the database, which should be accessible from any device with internet access, allowing remote monitoring of all STracker arrays. Here we have the front end mockup, which shows that our plan is to group the arrays automatically using JST, allowing us to dynamically add new arrays without having to update any of the actual the HTML itself. And then each array is populated by trackers showing the current elevation, azimuth, wind, and eventually power output of each individual tracker. Selecting a tracker will bring the STracker engineer to a detailed log of each packet received from that particular tracker. This is sorted from the STracker ID provided in the sample JSON packets that we've received from Sharp Energy, and provides a historical overview of the individual tracker status. Now moving on to Jeremy McNeil. He's going to talk a little bit about our testing process, our plans moving forward, and some reflections we have so far.
Hello, Jeremy McNeil. Currently, all of our testing has been done locally. we're able to take our JSON and parse it and send that data to the dashboard. Our functionality, we can display and sort our data coming in from the log and from the database. And as we continue to move forward, our text testing complexity will continue to grow as we add additional features. Our team roles. So Noah was responsible for setting up our server, and he was our primary point of contact with our client and setting up our weekly Zoom meetings. He's continuing to do back-end development. Daniel, responsible for the kind of overall architecture and the initial interface design. He's continuing to do front-end development. Myself, working on authentication security, integrating user authentication into the front end and ongoing documentation, as well as some support for the front end and back end guys. Reflections, so our successes and failures. So our successes, we have we've had steady client contact through weekly Zoom meetings. We have clear requirements from our client and a clear use case. Our failures, so currently we lack an ideal test environment. We've been doing our testing locally. We'll be deploying our dashboard online to our server soon. Adjusting to the constantly changing log files from the client is also an issue. So they have yet to settle on a finalized format for their log files. For example, we don't have power information in the log files yet. That'll be added by the client. So the exact format of the log file coming from the STrackers has yet to be finalized. So that's providing a bit of a challenge. Moving forward, user authentication. So security is going to be an important issue. We're currently planning on storing our usernames and passwords hashed in the database rather than stored in plain text. Our front-end landing page has to be developed. And from our dashboard mockup, we need to improve the overall look of the dashboard. So we'll be adding charts and beautification to the project. As we do that and add additional features, the complexity will grow, which will have an effect on our testing. So we'll continue to work on that. We'll be developing individual pages for the trackers. From there, you'll be able to see the logs and sort them as needed. Currently, our power generation information isn't being sent via log, so that will be tracked and displayed on the dashboard once that gets finalized by the client. Our client-side log file format, like I said, yet to be finalized. And then the deployment of our site, our dashboard online, will allow us to do our live server environment testing, which will be a more beneficial. That we'll be able to get live data coming in from an actual tracker to the website versus doing local testing without incoming data. In conclusion, working with our client, teamwork, and real-world experience. We're looking forward to the opportunity to continue to work on this project and bring improvements for our client. Thank you.